Ouais, non, je peux pas parce que je suis sur le stream. Je suis légèrement sur le stream. Je peux pas envoyer, je peux pas changer. J'envoie dans le stream. Oui, oui. Mais sinon, après, dans l'habillage, ça c'est pareil. Si tu veux ça à la place du contenu, dans l'habillage, il faut le préparer avant. Parce que j'ai cru comprendre que tu veux mettre ça dans la fenêtre, ça dans la grande fenêtre. Ouais. Ouais, pas de souci, il vaut mieux avant.
Hello, will this delay too
Bien
much?
sûr, bien sûr, bien sûr. D'accord. Ouais, ouais, ok, ça marche. Pas de souci.
Did you check with Wanda? Hi, I'm Vincenzo, I'm the first speaker. Did you check with Wanda Diaz-Massad that she's connected?
Oui, oui, elle est connectée.
Okay. Okay, and also Mario Salvucci. There is another one, Mario Salvucci.
I am connected. Hello?
Sorry, there is a microphone like that. I can use this one.
1, 2.
Okay, and for
Shall we
changing
begin?
the slide.
Oui. Ça marche. You click here and your presentation start.
We'll go, okay. So I think perhaps we can start. What do you think?
Comment?
Can we start?
A priori, oui, je pense.
Guarda, se riescono a vedere, diciamo.
Hi, everybody. Sorry, I'm the chair, but I'm a few minutes late in finishing my lunch. Are all the speakers here?
No, I'm here, and the other two are connected online, but I'm not
Okay.
sure.
So you're the first speaker? Okay. So do you want to wait for a few minutes to see people come, or shall we start with this audience?
Also wait another couple of minutes.
Let's just wait maybe a little bit. Thank you.
Sure that. You will, because the first one is a panel. Three persons.
yeah.
So you will moderate the panel. I have to do.
So let's start this.
This one is my presentation, but
Yeah.
then there will be other two.
So how long would you present? And
We have a panel of 1 hour,
yes,
and then two talks afterwards.
yeah.
not
So your
connected.
presentation is for only 10 minutes, right?
No, my presentation is long, is 15 minutes because we.
Okay, that's fine. Okay.
So we have three presentations, and then if you want, I can share the panel. It's up to you.
Yeah. So yeah, we can kind of do jointly. That's fine.
Okay.
Perfect. Yeah, that's fine. I think the restaurant, people at the restaurant are running late. I think almost very sure we are out to eat inside. it's okay to go. I'm assuming it's nobody stopped. I know, no, this lunch situation is impossible. So, welcome back, everybody. There are two panel sessions happening right now on diversity, inclusion, and equity. This is one of them. The other one is happening parallelly. But I think since the recordings will be available, I think we can all share them later. So first, we'll have Vincenzo Nepolana. He's going to give a talk, followed by a panel discussion. Before that, I just want to announce that many of us have stickers and flyers to give away, and many of us want them. So there's a table now put at Sirius, the room near the plenary room, where the posters are. And so you can keep your stuff there, you can take stuff there. So just to let you know that, yeah, please.
Hi, everyone, and thank you, the organizer, for accepting this panel. I'm Vincenzo Napolano. I'm the head of communication of the European Gravitational Observatory. That is the home institution of Virgo, that, as you know for sure, is one of the three gravitational wave detector in the world. The three of able to detect gravitational wave, to LIGO and Virgo. Then there is Kagra, but it's not still online. I will present like a general frame for our discussion today. Together with Wanda Diaz-Merced and Mario Salvucci, we imagine to have like a discussion that is between the art and science connection and also the engagement and the inclusion that you can have with a multisensorial approach to, let's say, reality in general and outreach in a specific way. So I will start with I hope, not more than 15 minutes of presentation, then Wanda will follow, and then Mario Salvucci. I will present them before their talk. As I said, Virgo, I already said, is a gravitational wave detector. EGO is the institution that hosts Virgo. All this is very close to the Leaning Tower of Pisa. As you see, is a detector L-shaped with arms of 3 kilometers. But I will today, of course, not go inside the details of how Virgo works. The main point here, that is the starting point of our reflection, is that we are facing, as you know, in astronomy and in astrophysics, a kind of change of paradigm, let's say. So something that happens since a long time ago, but is increasingly becoming very important. So the point that we are observing the sky, the cosmos, not just with our sea, not just with telescope, not just through electromagnetic waves, but also detecting other signals, that's gravitational wave, neutrinos, particles. And so we are able today to like observe different phases of the same astrophysical cosmic phenomenon. That's quite straightforward, probably for all of us that are inside this field. Of course, it's not so straightforward for the general public and for, let's say, our shared imaginary. So in a sense, since ever, new astronomical knowledge, new cosmological vision since the ancient Greek up to Galileo and ever in the human history, we had that drastic, important change in our cosmological and cosmic vision had a very important cultural impact. through the arts, through the philosophy, through the human culture at large. And that's perhaps happening even now, because of course in the last century we had a drastic and very important change in our vision of cosmos, let's say from Hubble on, and I guess I think several people think that also this change that someone called scientific revolution connected to gravitational astronomy and multi-messenger astronomy, so the capability, as I say, to detect the same astrophysical event through a large spectrum of discrete signals, in a sense is a scientific revolution from one side, but is also stimulating and inspiring a kind of new cosmic imaginary. What we can do as a research institution or as a public engagement or communication expert is probably to support the connection between the scientists, this new vision, this new knowledge, and several, let's say, cultural stakeholders, let's call like that, artists, philosophers, in general, tutors, in a kind of co-creation of a new imaginary. It's a very ambitious plan, it's a very ambitious goal, I'm aware of that, but I think that that general frame is crucial to understanding the direction where to go today in communication and outreach, both in astronomy and fundamental physics. In our case, in the case of gravitational wave, the leading metaphor in the narration and the storytelling connected with gravitational wave discovery is the metaphor of listening to the cosmos. No? We say everywhere, now we are able to listen to the cosmos, not just to look at the cosmos with our ears, but also to listen at that. Up to now, we were like watching a movie without the sound. Now we have the sound too. Of course, this is a metaphor. Gravitational waves, I hope you all know, are not sounds, are like the formation of space-time. It's a very, very complicated signal. But we can sonorize it. And in a sense, the fact that the frequency of the wave that we have detected is so close to the frequency of the acoustic wave, and also the fact that actually these as waves that are like deforming and propagating around a medium, even if this medium is the space-time itself, make this metaphor effective and make this metaphor very inspiring from the point of view, again, of storytelling from one side, but also of giving us new tools for public engagement. The first one, I will jump this and go to this, and then I will come back. The first one is the data sonorization. No? So we can following this metaphor, sonorize the data. That's something that we can do, as Wanda probably will say later better than me, for gravitational waves, but we can do also for other kind of signal. So this is the sonorization of a gravitational wave signal that come from a very remote event, a merger of two black holes, like 1 billion years ago, that after 1 billion, after traveling for 1 billion years through the space arriving to the Earth, and the two LIGO detectors were able to catch it. So this is the sound of the first gravitational wave signal ever detected. And if you look at the visualization of the same phenomenon, that is very, very like made in a slower way. Actually, the shape of the signal of the sound signal, of the acoustic signal, resemble perfectly the different phase of this merger. So you have two different ways to see the same phenomenon. And in a sense, in this signal, there are much more information, because information about the energy, about the mass of the black hole, about the speed in which the merger happened, and so on. But I want to go through this in a very detailed way through this, also because I'm not an expert of sonorization, but just to say that just the sonorization of the data offers you a wide range of new possible ways to tell to the people about what we are studying and the way we are studying. At the same way, in a quite natural way, multi-messenger astronomy, as I said, inspires us to look at the data and in a sense also to reflect on a possible multisensorial approach to the world reality. So if we start to think, okay, these are the data, but basically we are used to see this data to display as a visual, with a visual medium, but actually we can also listen to them. Actually, we can also transform them in vibration, like in a kind of haptic experience. So you have a kind of opening of several new possibilities that you can apply in general to the exploration of the reality. What I mean is that in a quite natural way, if you are telling to the general public about multi-messenger astronomy, you would use a multisensorial approach, not just displaying things, but also 10 people listening things, 10 people touching and feel vibration. And Wanda Diaz-Merced, that you will listen after me, will say more and is the real expert of all these field. In all this, of course, there is also a message of social inclusion, but it's not just a matter of inclusive outreach. So, in a sense, this multisensory exploration of reality is an improvement of our ability to perceive phenomena in a general sense. So, teaching us to better understand the cosmos, but also to better understand the reality around us. So it's not just in this, I think this is an excellent example as how inclusion can become at the same time a kind of improvement for all the other people that in a sense generally do not need to be included, let's say. And that's one side of the question. The other aspect is that, as I said, is quite true in general that the most important scientific achievement always have a kind of counterpart in our way of conceiving the human being, our place in the cosmos, and so on. I already said it, but I would like to emphasize very much because at least at Ego in our communication strategy is a crucial aspect. So, also in this case, this new multisensory observation of the universe offers inspiration to artists, to musicians in a very natural way, to thoughts, to philosophers, to intellectuals. So it's straightforward to say that listening to the sound of the universe is a great suggestion for all these people. And I will give you now very shortly some example of the collaboration that we were able on this base to build together with several artists around the world, especially artists. One is with this very famous artist, Argentinian artist, Thomas Saraceno, who is interested in gravitational waves since a long time, and he built in Palais de Tokyo in 2019 in his exhibition on air this installation that was called Algorithms that is a kind of artificial web. I don't know how many of you know the work of Saraceno. That's, as I said, is a kind of start of contemporary art, but he works a lot with spider web. In this case, he built a kind of artificial web, with several wires, wires, let's say, of different shape connected in a very special way. That's very nice, of course, as a very important aesthetical aspect. But let's say the adding value was that Saraceno planned to connect each of these or some of these wires to a live transmission of a cosmic signal. So we succeeded to connect in front of this web. The web was very big, a whole room bigger than this one, completely occupied by this web. And in front of that, there was this kind of I don't know how to call it, multi-messenger room. I'm sorry, there is no water now. Okay. I'm sorry for that, in which we were able to connect the Palais de Tokyo with live stream signal for several telescopes on the Earth, in the space, like gravitational wave detector, the Fermi satellite, gamma ray burst detector, neutrinos detector, and in a sense, any time that there was a detection, we were able to connect. Thank you very much. Excuse me. To connect this room with the experiment, and Saraceno invented a way to make the different wires vibrating in correspondence to in a different way, in correspondence of these different signals. So you have a kind of cosmic net, cosmic web, in which you have the different wires vibrating in a different way, but listening in real time, almost in real time. Let's say, of course, it's very complicated for a technical point of view, to the facility, to the antenna, to the telescope, they are observing and listening to the cosmos. Something similar we did in 2021, if I'm not wrong, in Rome. I will listen. Oh, I'm sorry. If I'm able, I let very quickly listen to you to the sonorization made by Saraceno. The idea here was to mix sound coming from spiderweb for the very microcosmos, natural microcosmos, and from the far cosmos, gravitational wave, a different signal. And there is a kind of entanglement of all these signals. There is exactly the artistic message of Thomas that is the one to say, okay, everything is connected in a strange way, and we have to really reflect to our place in the world. But I want to go too much in his work. Another interesting aspect, and then I will go close to the hand of all these, is that at the same time, listening the cosmos, we have to listen very careful all the environmental data that are around us. No, all the data, all what happens around, for instance, gravitational wave detector, but something similar is true also for other facilities on Earth. So the wind, the atmospheric phenomena, but also the human action, the anthropic movement, everything is a kind of noise, because as you know, the gravitational waves are very flexible signals, so are very weak signal, and the detection is a very challenging effort. So you have kind to be in the most silent and quiet place in the world. And for doing that, you have at the same time listening, everything is happening. Oh, yes, I'm sorry. Everything is happening around you. And that's another source for sonification and for telling a storytelling about what it means listen to the cosmos. It means also listen to the Earth and so on. And also based on these, there have been several experiments with artists. This one is an artist that made the Spring of Vivaldi sound inside the detector for showing how much noise could be for the gravitational wave detector, something that we consider the top of the nice sound become a noise for the detector. Then we had several events connected to this idea of sound, environmental sound, the mixing of environmental sound and cosmic sound. And this one is another artist that worked on that in 2022, Massimo Magrini, but I let you know a few seconds. This is an installation with Mario Salvucci that you will listen later as works about Einstein telescope and what it means listen, what it means to see. This is a podcast and several other aspects connected with sonorization. This is the next, let's say, experiment that we will do, a kind of immersive multi-messenger one, in which we will mix sound and images, offering the people a kind of travel of the origin of the universe. And the final message is that, of course, the crucial point in all these is that you should have a collaborative effort. So you should be able to connect together musicians, artists, science communicators, scientists, and so on. And I would really want to thank a person who inspired in a crucial way all this work, that was the previous EGO director, Stavros Castanevas, that unfortunately passed away more than 1 year ago. And here he is together with Bob Wilson, that I know if you know, but he's one of the most renowned theater director in the world. Thank you. I guess we can have...
Yeah, we can have a couple of questions about the talk itself before we move on to the panel discussion. Is that all right?
Yeah, otherwise we can have also the question afterwards, as you want.
Okay. Any quick, urgent question you have to ask right now? Then we can take that, and then we can then move on. If not, then let's then go on to the panel. They'll be joining us. So the two people online will be joining us here. So along with the speaker, we have Wanda Diaz-Merced as well as Salvuki. They are from CNRS Paris, as well as from Rome and Puerto Rico. So I think just like multi-messenger, we also have people from various cultures coming together to kind of present things in a new way. So I think that's really good. So would they want to present something first, or would you just start the panel discussion? How would you like to do that?
No. Wanda will present something now.
Okay.
We have presentation.
Okay. Wanda, can you hear us?
Hola.
Hola.
Hola. Okay, so please start.
Hola. Hello.
Hello. Yeah, we can hear you well.
Hello. Hola.
Hello, Wanda, we can hear you well.
Hello.
Hello, we can hear you. Is there something muted at our end?
Estoy conectada.
Can you hear us now?
Estoy conectada. Hello.
Yeah, hi, can we hear us now?
Yo voy a empezar. Ahora escucho un murmullo. Hello.
Hello, can you hear us now? I just keep saying that till she says yes. Hello.
Ahora escuché.
Oh, perfect. Yeah. So Wanda, please start
Shall
your
I
talk.
begin?
Yes, please begin. Yes.
¿No? Se dejó de escuchar. Qué triste, ¿eh? Hola. Es importante esto. Hello?
Can you hear us now? Maybe you could type in the chat that we can hear her and she can begin. Is that possible?
If I can't hear, if you can hear me, send me a chat line just telling me when I should begin.
Yeah. Maybe I can.
I heard most of Vincenzo's presentation. But I hope they're listening. Hello? Hola. Mana, ¿no me puede enviarles una línea? Sí.
Hello, can you hear us now?
Hola.
Hello.
Ok, ahora se escuchó algo.
Is there a separate chat through this, apart from the live chat?
Hello.
Can you hear us?
Okay, okay, yes.
Oh,
yes.
perfect. Okay, yeah, please start. We can hear you well.
Okay, thank you.
Yeah, sure.
Thank you so much. I apologize for the delay. Vincenzo, thank you so much for organizing this panel. To many more people I know, is very, very important. It's crucial for multisensoriality to have a wider framework, as you have mentioned, a framework that will provide for us to do the science, but also will humanize our science at all aspects of practice, from education and people outreach, communication to storytelling, and also for the professional performance. I also want to mention that OEO, and even though he's not directly related to OEO now, I have always supported and will support the work of Agata-san. In 2020, when he was the director in a very simple study, when I spent a couple of months at OAO, in a very simple study we did under the supervision of Agata-san, we did examine the presentation of knowledge within astronomy. At that moment, and not discarding the changes that have taken place in the last decade in the speech or discourse in astronomy, and the initiatives that are currently ongoing, not discarding those. The simple study we carried felt like a very interesting case study because astronomy is a science that seeks to attract the most audiences. It wants to attract everyone to the field at any aspect of practice. At that moment, what we did was to perform a very simple linguistic analysis and a journal author guidelines analysis. And included in that analysis, we included, but it was not focused on accessibility guidelines. We included it, it was not focused on accessibility. The results we got led to identify expectations and commonalities between authors and the consumers or receivers of information. Those commonalities were that first, that both share the same sensorial modality of interaction, that the second, that both share the same access to information, the third one, that both share the same linguistic knowledge as authors, another one, that both share the same cognitive strategies to build knowledge. And another one was that both share the same socioeconomic status and background as authors. It means the same access to information in terms of socioeconomic factors. Because I am very lazy, that characterizes me. I grouped those in the category of generalizations, meaning expected generalizations from authors who communicate the information. I sure hope, and I hope every single day, that we were not writing our findings. Someday, very, very close by, someone will prove us wrong. Because if it is true, what we found, as I call those generalizations, is a factor that may lead people to feel that he or she may not be really taken into consideration. And that those things are like little pebbles that may bring people to feel inadequate by the information, and that there are no choices but to submit. And sometimes submit in terms of resignation, right? And sometimes we submit by withdrawing. Those commonalities, right? I am so sorry I said those negative things, but I also think that those commonalities that we identified are filled with opportunity. So I landed in Italy at the European Gravitational Observatory, and it was my mentor, the late Dr. Daisaku Ikeda, who caused that shift into the perception of those commonalities. From Dr. Ikeda, I witnessed that he perceived the various information tools and methods that we use and we have at our disposal It may be digital, hardware, like books, etc., that he perceived those tools as extensions of our senses. And that it is the experts on communicating the information, you call it teachers, parents, journalists, scientists, others. It is, it is, it is them who bear the responsibility to consider what and how the information is passed on and or communicated. And our choices as people that receive the information and consume the information and our reactions to that information depend on those considerations. He perceived beyond and wanted the data to be used symmetrically for serious aspects of research, art, philosophy, and education and people outreach. I would say without fear that the paradigm change that Vincenzo mentioned earlier is thanks to the late Dr. Katsanevas. So what we did in order to address those commonalities was that he had me working, and Vincenzo was part of the team. He had us working on a multisensorial astronomy book. I call it Astro Signals Unbound. It has no title yet, but that's how I call it, in which the concept of signals serve as an expedient means to use multisensorial perception to go beyond the electromagnetic spectrum. And if people choose to do so, on each chapter, perform data analysis, like the serious data analysis. But people choose. This is what multisensoriality offers. It offers a diversity of ways to approach the information and augment our sensitivity to events in the information, but also it offers choices to the people. All of this utilizing multisensorial tools and methods that we have been prototyping and testing. On a multisensorial course, we began under Dr. Katsanevas, which is this multisensorial course. We use it, is carried every single Tuesday in the afternoons in Puerto Rico. People from Australia, United States, Italy. There is one French person, but in English, right? That connects to the course, and in there using co-creation and using the stories of each of the people interested in participating in the multisensorial course, we test everything we co-create. And as actual proof, the participants have been in the course. The course have been running since 2021, and since 2021, we have some of them coming constantly to the course, and I think they should get a diploma. They know more than we do. In terms of education and people outreach, also we have begun training. We have begun performing training to teachers, being the last one on May 22nd, 2024 at Universidad del Sagrado Corazón, where 53 special education teachers experience multisensoriality and also using multisensorially diversity of experiences, like calculating masses of black holes, coronal mass ejections, etc. They also experience sonified, meaning real measurements translated into sound or brought to the audible domain, haptic and visual display. The initial testing of methods also created specifically by the student Shane Kendall when we were at the European Gravitational Observatory. Dr. Katsanevas mentored him to use audio, right through me, to use audio to produce low frequency and low sound pressure levels of the sound to separate signal from background noise in the information collected by the gravitational wave detectors. And he got very good result, and results were presented at the sonification panel. This was the very first panel considering sonification for scientific analysis at the Cosmic Ray Extremely Distributed Observatory in Poland, part of the Polish Academy of Sciences, where they also applied the multisensorial techniques for cosmic ray analysis, dark matter, but then, as Vincenzo mentioned, extended the participants, and they extended the methods to the identification of bot attacks in medical information. Considering, just to finish, right, because we're a little bit delayed, considering the changes occurred during the last couple of years and also in the last decade, to me, this work that the European Gravitational Observatory is carrying, and we adopted in Puerto Rico, the Universidad del Sagrado Corazón, thanks to the work of Vincenzo and Dr. Castaneva, it has the power to collaborate with you all to prevent the further broadening of the development gap caused by the approaches to knowledge, performance, and production styles that have been caused by the halted development of multisensorial methods. And it also provides for its application to human factors, which may have contributed to forms associated with other types of sensory experience and the prevalence of uniform ways of communicating. We are little by little, through this work, what we do is that we are little by little observing scientifically how effective it may be, the application of these methods on research, but also we are also trying to slow the custom of diverting the usage of multisensorial methods for only education and people outreach without giving a way of doing a transition to any performance aspect that we decide to participate on. It may be education and people outreach, but give me the sense that I can progress. So in that way, trying to humanize information approaches in all aspects of our sciences. Thank you so much, and I apologize for the delay and that I had to shorten the presentation. I apologize. Thank you.
Thank you, Wanda. Thanks for joining us. I think after Wanda, we'll have Mario Salvucchi, after which we'll have a general discussion. So Mario, please, you can start your presentation.
Can you hear me?
Yes. Yes, we can hear you.
Okay, perfect. I have something to share on screen. Can you see?
Yes, we can see it.
Okay, fine. So, hello everyone. I'm Mario Salvucci. I'm a musician, sound designer, software engineer, and the chair of electronic music at the Conservatory of Santa Cecilia in Rome. I will talk about sound, provide some short cues on how it works, and 3 samples from art installations using sound. Unfortunately, the streaming is not so good, so I will send a YouTube link with, if you want to hear with better quality. So, sound is the basic element, one of the basic elements of our life, and we relate to the world using hearing and other sensing, such as touch and sight. To ensure a complete experience, it is crucial to design and integrate correct sound components. Obviously, there are limitations in a sound-only perception, but sound remains the main indicator of the effectiveness of the interaction. But where does the idea of data sonification come from? The idea comes obviously from data representation that was born as a practice history focused on data visualization. You can see the snows map is an early example that revealed that people affected in a viral outbreak drank water from the same pump. Data sonification started shortly after that, in 1908, with the Geiger counter that we all know that's the earliest example of data sonification. After that, there were many cases representing data with sound up to the academic definition in the 90s. There are many ways to use sound in data representation, and they can be categorized according to the method that they use. The first one is auditioning. The audition parroting. In the audition parroting, the values are extracted, and time stretching and pitch shifting techniques are used to bring them into the audible range. An example of this is the work of a seismologist, Hugo Benioff, that in a record out of this world accelerated tape recordings of earthquakes to the point of audibility. Second category are non-verbal cues. Non-verbal cues are ear cons and auditory icons. Ear cons are synthetic, discrete audio messages representing events. think something like phone notification or barcode scanner blips. We can develop an audio language which can not only make dataset accessible, but can improve the experience for every user. Auditory icons are real-world sounds associated with elements of the dataset. For example, the sound of a cash register associated with sales operation, and that leads to a specific aesthetic. The third category we have is mapping. Data is mapped to different audio properties like pitch, for example, just as display involves mapping data to visual properties like color or shape. There are continuous mappings, volume or duration, for example, and discrete mappings, like number of times a sound displayed or type of instruments used. But also mappings that can fall in both categories. The pitch is an example. Think about a violin. The player can execute all the notes between different positions on the fretboard, making a continuous glissando or frequency slide instead of quantizing on notes of the temperate system. So the sonification is designed to help to connect intuitively and emotionally with some kind of event represented by data. Often there is a need to make data more acoustically pleasant, but representing data is only a part of the sonification work. It is necessary to establish an emotional connection with the listener to give something he can remember. Unfortunately, the dataset cannot always provide an evolution that involves the viewer, so it will be necessary to make some arbitrary choices, and emotion is an area where music and sonification have an advantage over visualization. For example, think about the graphs of the global warming. Lines don't communicate urgency as a sonification can. So to operate in the right way, we need to tap into the meanings of sound. For example, we can represent building collapsing data with beeps, but these don't have the same emotional resonance as the sound of building collapsing. So this process of representing the data with sound becomes more difficult when encoding the data to music. What happens often is that systems for mapping complex parameters need to be learned before they can be understood. So listeners need to keep in mind the data mapping while listening, and may have to listen multiple times to train and understand the sonification. It's the same that happens in visualization of a complex chart, where the reader has to spend several minutes before understanding the information contained. Regarding the relationship with scientific sonification, one thing to keep in mind is that data are something objective, but hearing is something subjective. So when it comes to translating data into musical elements, we find that hearing is highly skilled in detecting pitches and patterns, but this can change from person to person. So the goal of the sonification and of the sonification artist should be to find a way to produce something understandable from the most of the public, also through data manipulation. In a musical sense, in a musical sonification, we link to a specific context, the musical context, and we have some terms. So pitch, that is the frequency of sound, in music can change in many ways. Can change horizontally with melodic profiles in time, vertically with harmonies, or in other ways, depending on musical styles. High pitch and high values are not always perceived as tied. High pitch sound can be associated with small values because they are perceived as thin. Then we have rhythm and time, the duration and temporal arrangement of sounds that creates a temporal structure, such as the beat of a song or the movement of a dance. These include the duration of events and the notes, the meters, that is the division of time with accents, for example, 3 on 4 or 4 on 4, and the pauses, the punctuation. Next is the timbre. It's the color of a sound depending on the acoustic spectrum, and is driving the emotional expression and perception of music. And last, spatial properties that is related to the characteristics of the performing space. So I provide here some examples. The first two are on Tumblr. Here I have some data from LIGO, already converted to audio from Vincenzo. The first example use an audio filter cutoff frequency to deprive a complex spectrum of its component, giving the perception of the change in time. The other one, the second one, uses the same data as an index of aggregation and drives the sound from an entropic noise to a musical chord. I use a well-known sound that is the THX sound, chord sound. Let's listen the first one. Can you hear the sound? Sorry.
You'll have to share your audio when you start.
Yes, I shared without audio. Yes. Right. Okay. So it's right. It's can you hear? It's okay. Okay, perfect. So the second one, first you hear the original THX sound, followed by the sonification with the LIGO data. And here comes the LIGO. Okay, so another couple of examples here, sonifying moon craters. You can see the data here are sort of a spreadsheet. The first one sonifies the dataset with diameter inversely mapped to pitch and reverb length to give kind of an imaginary synthetic impact ear cone. The second one extended the sonification of musical instruments, but they say I have only 2 minutes left, so I think I can jump just ahead to let you listen this one that maybe is more interesting. Obviously, time is organized also at higher level in form, in music. So when the data don't give this musical form, it's necessary to create a form linked to a storytelling that involves the viewer. So this often is given by connected mediums, such as video or tactile environments. And in the next one, in Mistero dell'Origine, the visual storytelling is given to projection mapping. And for sound and music, data from various sources that are probes and other types of data, of sensors, are used as non-verbal cues in conjunction with sound design and composition. This up to the end where the data generate the closing melodic line. So I'll send this one to you. Okay, I think we are short on time, so I don't know if I can show something else or I have to close.
We don't want to listen to one more? Yeah.
Can I show one
Yes,
more?
please. Yeah.
Ah, okay.
Yeah.
Okay. So I show this one, this neural mirror. Here is a real-time data sonification where the data set comes from the public. The mirror is an object that reflects the visitor in a digital image, and an AI system tries to identify physical tracks like gender, age, and emotions, like Capture said, generating data. Data are conveyed to the audio engine that use them as rhythmic elements mixed with sounds from plotters writing the data on paper, and as modifiers to an audio vocal texture related to the location. Okay, so I think I have
Thank you, Maria.
close. Thank you. Thank you.
You can join. Okay, you can stand there or join here, whichever you're comfortable with. Okay. So we have some. So we have around 9 minutes because we started a bit late and there were tech issues which I discounted. So we have questions, comments about very interesting presentations, which tells you not just that you sonify data so you can hear it, but then it's also a totally new way of looking at the data itself. So multisensory, a work like this is also a new way of looking at what data is, not just for the public, but I think also for professional astronomers as well, to kind of have a different way of looking at various aspects to multidimensional data. So I'm sure there are a lot of questions or comments also from your own work or experience. So please, go ahead. I'll pass the mic. Yes.
Hello. I work in a museum that is basically for kids. It's for everyone, but it's basically for kids. And we were trying to come up with a way of explaining these things to kids. And I was wondering if you have thought of that, and if you have any recommendations for that specific public. Thank you.
Maybe we can take both questions and then we can answer them together.
I wanted to ask what is the general feedback from astronomers about the results? Like it sounds super cool, but from the scientific community. How do they?
So we'll take these two and then come back to. Oh, similar. Okay.
So in the other side, I want to know what's the general feedback of these activities, what people really understand about the concept you are trying to communicate. Did you ask?
Yeah, so Wanda and Mario, if you didn't hear the questions, the first one was about adapting this for children, especially kids. And the second and third questions were, what is the kind of feedback you got in general, as well as feedback from astronomers? Yeah.
Okay,
so
probably I can reply to the first one, and Wanda, I let you reply to the second. It's fine. Do you hear us, Wanda?
Yes.
Okay, so
yes.
I will reply
yes.
to the first question. Actually, we have a small activity for children at IGO based on this idea of using the sounds. That's basically we let the kids to listen to a kind of overlap of several sound and noises, like an earthquake, the sea, the wind, all mixed together. And inside these, there is also a gravitational wave signal. So with Wi-Fi headset, we let the kids listen to them, and they have to recognize the different sound. And after recognize, we cut off from the mix. And at the end, they let with just like discovering the original sounds. This is just an example. But the general message that I would say is that this field of using also in a very deep way the sound, the multisensorial, also the vibration for outreach is at large not yet explored. So I think there are so many things that you can imagine, do. Just start to think that you can do it. And then it would be, in my opinion, the feedback is good from the public. So there is a lot of appreciation. We have not done a very careful survey on that. Okay, Wanda, I'd let you reply for what concerned the astronomers' reaction. What do you think about this?
Thank you, Vincenzo, and thank you so much for the question. There is an increase on one side. There is an increase on papers where professional astronomers use audio in order to explore information. That says they explored information, they perceived events, and they published. That is one aspect, but that doesn't say anything about what is the real reaction. The real reaction of the astronomers is that it is a very high learning curve, because they have been 17 or 18 years learning visually in school, and then to do the transition to use audio and visual perception or audio only if they choose, right? I'm talking about the person that is sighted. It's a little bit of a steep learning curve. So one of the things that they have been asking for is to identify what combination of attention modalities enhance or hinder identification of events and the design of a training paradigm that will be low learning curve and also time effective, that will make the exploration time effective. We are right now working on that, and Vincenzo has been really humble. And Vincenzo, don't be humble. Right now, we are also working on haptic modalities. We didn't show it because of lack of time, but we hope those haptic modalities will also give us some insight on what attention. A combination of attention mechanisms we may use or suggest in order to get started with the data analysis. But there is an increase of papers of people using audio for professional analysis.
Thanks, Wanda. Yeah, I think even on AstroPH, if you follow it, now the increasing number of papers on sonification, both by science communicators, also by astronomers. I think that's a good sign. And I think, like Wanda said, and you also said, this is ideal for artists to kind of come in, right? So artists usually, you tell them, oh, there's a pretty picture, and then that's it. But now you're entering their field, and I think it's much bigger arena for them to play with than before. I think that's fantastic. Other questions and comments?
There was a question,
No, it was the same questions.
No, actually, I have
Yeah.
a similar question on what do people get out of it if you have a study.
Okay, from my side, no, there are, okay, one that, as she said, did a lot of studies about the use for research. For what concerns outreach, I have to say, there is, at my knowledge, there is not, let's say, a scientific survey about the feedback and exploring the, so what I can say that there is a quality appreciation, but, you know, that's, that could be always true or always false. It depends also from your perception.
Okay, thanks. Other questions or comments?
If you allow me to add to what Vincenzo is saying, I didn't hear the question, but I don't know if I should mention this, but we got a tiny amount of money to run the experiments on attention mechanisms applied to simulate data, right? We have to simulate data, then apply to real data, but also to translate things to education and people outreach, specifically to the creation of curriculum and learning in schools for children from 5 years old to children from 5 years old to 155 years old, and if they live longer, then it may be. But those experiments are designed and up to start piloting or getting data in July when the student arrives to Puerto Rico. So we will have more news next year if we assist to the CAP or whenever the CAP happens again.
Thanks. Yeah, thanks, Wanda. Other follow-up questions or comments? Your own experiences in doing this, for example? Yes.
Hello, this is Erika Labe. Hola, Wanda. I'd like to know if any of you have found something that you didn't expect in this work with the sound plus the vision, because that's very typical when you work in inclusion, as I do, and I would like to know your experience about that.
Hello, Erika. Nice to greet you. Very good to find you here. It feels that we are together. Yes, I have found events that otherwise wouldn't have been spotted with the eye in different astrophysics data set and also cosmology, cosmic rate intensities, the data sets. I cannot say it is because I'm totally blind or because I pay attention differently than sighted people. I have to say that it is because I use another sensorial modality to enrich, right, what my exploration styles are, and that I can modulate those that display of information as to feed the most the sensitivities that I have. I can say that now. In a month, ask me again, and I will talk from the data. When the data talks to me, then I will be able to tell you, no, it is because one that was combining X or Y unwittingly or autonomously. Because as for now, the combinations I use are to enhance my own sensitivities, but are not based on results of scientific experiments. In a month.
Do you have anything to add?
No, I want, if I can, I want perhaps like to give this question also to Mario in a slightly different sense, because from his presentation, from your presentation, Mario, I think you showed very well how there is a kind of expectation that you have already also before let's say the artistic elaboration that you want to extract from the sound, no? For instance, in the
Yes.
case of gravitational wave, you emphasize a lot this sudden and very strong event at the end. So it's like that, or sometimes, as she asked, you then working on the sound found something unexpected.
Well, probably the point is that very often the data, as they are, don't provide a story that tell something, a storytelling that can involve the listener. Other times, maybe you find something very, very strange that can be included inside a storyline. So the point is just to find the right way to emphasize something that sounds important to the public. I don't think it's only a thing of doing the data as they are, but it's also manipulating the data to abstract some concept to communicate to the public. So this is the crucial point of the sonification. On the other side, for the scientific exploration, is another thing. Because sounds have to be mapped linearly, directly to data. So the scientist or the one who is using the sound to represent the data can hear the variations, for example, in pitch. But as I said, very often people is not so skilled in recognizing the variations in intensity or the variations in pitch. So this activity most of the time requires some kind of training to be able to interpret the data.
Thank you, Mario. I think we'll have to stop there. So thanks again to Vincenzo, Wanda, and Mario for a wonderful session on things I think all of us are going to learn from and practice over the next many years, I'm sure. Thanks again. Our next speaker is Matteo Isidro from SKAO. Radio, he's from a square kilometer array, which also does a lot of sonification in terms of potential, but I think he's going to talk in general about the outreach efforts. So yeah, 10 minutes. At 8, I will kind of remind you at 8 minutes. So then you have 2 minutes to
I realize Claudia and I are keeping you from coffee, so I'll try to not go over time. I'm gonna, well, first of all, I'd like to say that thank you for the opportunity to speak. And speaking here is a bit special for me because originally I come from not very far from here, about an hour from here. So I used to come here as a kid when I was into astronomy and amateur astronomy. So it's quite nice to get to come back and be part of the community. So I'm going to change tack a little bit. This is very much about how a communications team, you know, that does public relations and so on, and media releases and so on, can help with, you know, promoting equity, diversity, and inclusion, and what we're trying to do in terms of improving accessibility of our products. And it's by no means, you know, this is the way to do it. This is very much sort of, this is how we're trying to do it and how we're learning. So I'm here to get feedback from the community. So my name is Matthew Isidro. I'm Senior Communications Manager for the SK Observatory. If you don't know about the SK Observatory, that's my only slide about the project. So in a nutshell, big global collaboration, countries across the world on 5 continents that are building 2 major radio telescopes, one in Australia, one in South Africa. And it's an intergovernmental organization like our older sister organization, the European Southern Observatory, or like the European Space Agency or CERN. So we have a similar status as an international organization. So we get asked this a fair bit, right, by people. Why are we spending time talking about equity, diversity, and inclusion, yeah, or trying to do accessibility. And there's a few answers to that, right? And I'm sure everybody in this room is already on board with all of this, right? But we're a new organization, so that means that we have a unique opportunity to develop new policies and practices and change how things are done, right? It's not very often that there's a new intergovernmental organization in the world that happens every few decades. And so we have a unique opportunity to update how an intergovernmental organization does things. We're also a very, very diverse organization because we have more than 23 nationalities working for the SKO. And as I mentioned, this unique set of countries that brings together both East and West and North and South. So that brings in some really nice diversity. And quite interestingly, actually, so intergovernmental organizations have a treaty, right? We sign an international treaty that establishes this new body, and all the states kind of sign that treaty. And actually, in the preamble to the treaty, we speak about diversity and equality. So the parties, the governments that negotiated this treaty wrote that they were committed to an organization where diversity and equality are promoted and respected. So that's really nice because that gives us a mandate from the top to be doing EDI and accessibility. And then, of course, we talk a lot about the impact of astronomy in society, the wider impact of what we're trying to do. And many of you will be familiar with the UN Sustainable Development Goals. And they are sustainable development goals that address gender equality and reduced inequalities. So it's very much part of what we're trying to bring to our small contribution to society. So I'm going to skip some of these slides in the interest of time, and I'm very happy to talk to you about some of this stuff in more detail. I was the co-chair of the EDI working group for the SK Observatory. That basically our role was to come up with the recommendations for the observatory in terms of what we should focus on in the first few years in terms of EDI. So I'd be very happy to talk to you about all the stuff that's on there. But basically, we put together a working group, we developed recommendations, and it took about 2 years for them to work their way through the system and finally be approved and endorsed and released to all the staff to say, yes, this is what we're going to be doing, right? And those things focus on gender balance, on diversity that represents our member countries, and on equity of access to activities in general. That's some of the actions that are in there. The ones that I've put on there are sort of more specific, or at least communications can have a role in playing them, right? Of course, communicating our commitment to EDI, but also celebrating diversity through awareness days, having a clear statement on accessibility and trying to adopt best practice in terms of accessibility, and reporting publicly on diversity KPIs. So those are some of the things that my team works on and tries to bring to the table. And this is just to say, behind these top-level actions, there's 9 of them in total, there's a lot more content, right? So if we look at number 6 on accessibility, this is the detail of the action and what we should be doing, right? And specifically, accessibility should be adopted as a level 1 requirement for SKO platforms. We should produce and adopt guidelines where appropriate. And we should make sure, so in the case of communications, that the public website meets those relevant guidelines. And then we should have regular independent assessments of our platform. So it's very, very specific in terms of what we should be meeting down the line. And of course, that's communications, but that also applies to HR, that applies to our science and operations team. So it's really across the observatory. So focusing on what we do in communications, I'm going to talk really about social media and the website, because these are in a way, the low-hanging fruits, right? They're the things that we can do fairly easily and that we have control of. Basically what we're doing now, and this is what my team is responsible for, is all of the videos we put out, absolutely all of them, have got closed captions. And so we do that on YouTube, we do that on X, on LinkedIn, on Facebook, and on Instagram. So for those of you who are familiar with posting on those platforms, you'll know that it's fairly intensive to be putting, closed captions on each and every one of those videos on all platforms, right? It's not straightforward, something that's time-consuming, but that is very important. So we do that. That's a screenshot from an Instagram story that we did just the other day, and you can see the closed captions there on screen where we've got that. So videos all got closed captions. It's also a requirement for our suppliers that they provide us with closed captions when they make videos for us, because that didn't happen initially. So we've now got that, and then alt text. So some of you might have been in the James Webb talk a little bit earlier. That was on alt text. That was really excellent. So all of our images on social media have got alt text, right? And this is what it looks like on X. You've got a little ALT at the bottom of the image, and then you click to open it, and it sort of brings up the alternative text. So we do that for all images on social media. And then we've introduced guidelines for staff who'd like to post. So they're essentially just tips that we provide to staff to say, hey, if you're posting on X or on LinkedIn, these are the sort of things you can do to make your content more accessible. And we also train team members. So that's social media. And then website, that's a little bit, we're not as advanced in that. But basically, when we developed our new website, we made sure that accessibility was part of the call for tender, and that it was in the desired requirements for the website, right? So you really need to build it in from the start to make sure that it happens, because if you leave it to later, it's much more expensive and it's much more difficult to retroactively change things. But even with doing that, the website isn't completely accessible. So what we're doing now is we're doing an audit of the website, and it comes up with all of these things that are, basically wrong and not very accessible. And so we'll have to go back and make those changes, and that's not cheap. And then in a few months, what we'll be doing is we will do a deep dive in terms of getting accessibility training for the comms team. And then the idea is that we'll sort of share that knowledge with other staff members in the observatory and in other teams like HR and others on how they can make the websites that they're responsible for more accessible. And the peculiarity of our comms team is that we're also in charge of events, meetings and events. So that's something that we're also bringing, where we're developing guidelines for events. And I'll finish, I've got 2 slides. So just talking a little bit about what we do in terms of showcasing diversity. I mean, this is all quite common stuff now, but marking important awareness days. So we have an official calendar of VDI awareness days that we try to mark. That was International Day of Women in Engineering. That was on Sunday, by the way. So we mark that every year because we have a lot of engineers at the SKO. Making sure that we have diverse voices in all of our material and interventions. So that's looking at who we feature in media releases, in interviews, in videos, but also in talks, like when we have seminars, even internal seminars in the observatory, we keep an eye on the diversity of speakers, just to make sure that we do our part in ensuring that we have that diversity of voices. And then something that we do is a sort of, as a concept, is this sort of visible support, where we provide resources and assets and goodies and T-shirts and lanyards and stuff for people who'd like to express their support, and that works really well across the observatory. That's really a nutshell. Very happy to talk about this in more detail with people. What I want to focus on is the challenges of our experience trying to do this. And what we found is, I was involved in developing the EDI policy for the observatory, and it's a good policy, but a good policy doesn't mean good practice. You can have a policy that's sitting there on your intranet and nobody's looking at it, new people aren't aware of it, and it's not being implemented, right? So that requires constant, reminding. It needs individuals, champions who are, pursuing that, who are reminding their colleagues, who are assessing practices, and who are trying to embed it in workflows, right? When developing videos, when posting stuff online, putting out text, and in other teams in the observatory. So you need people who are going to do the actual implementation. The other thing we face is we don't have really dedicated resources for EDI or trained specialists, so we have to learn ourselves in our own time, to try and teach ourselves to improve our knowledge and to help others. And that's an issue, and you have to invest the time to learn more. And then finally, institutional change is really, really difficult and takes an awful long time. So what I can say from what we're doing as a team is, we've done our part in trying to help the observatory and in setting the policies for the observatory. And now we're focusing on implementing change in our team, right? In starting small, in looking at what we can change in our group, in our team, making sure that our videos are closed captions, our images have got alt text, that our events are more accessible, and it's an ongoing effort, right? And we constantly, forget to do things and have to remind ourselves. But that's what I would say if you're interested in doing these sort of things. Just start with your own group and start asking questions about what you can do in your team at your level, and then the institutional change will take time. And I'll leave it there. Thank you.
Thank you, Matthew. I think the last slide is something a lot of us can relate to in our own work and our own institutions. Maybe one very quick question, and then we'll have to move on.
Hello. Well, there is so much things I don't know about accessibility. I learned, so thank you very much. And of course, you did all these actions to reach out other audience, so people who need special things to. But do you know if these people is actually using what you produce? And there is a way to know, because I think it's like too personal, maybe. So
no, that's a great question. So no, I don't have that. I don't have that feedback. But from the talk that was given just a little bit before by the James Webb team, so they gave this talk about using alternative text, and they're quite more advanced in doing that than we are. And they showed at the end of the talk the feedback they've got from internet users, right, from Twitter users and others who are saying, I don't know who you are, but I'm visually impaired, and like this alt text was so beautiful, and it really helps me to understand the image. And so that happens, right? If you do it, people who need it will see it, right, and will benefit from it. But directly at SKO, I haven't had that feedback yet from users. But we take the approach that we. It's also worth saying that people, with different levels of accessibility, or if I focus on disability, people will have a disability at some stage in their life, right? And people will have temporary disabilities, right? And I think one of the statistics is, I think it's 16% of the world population has a disability, right? So if you're a taxpayer-funded project, the approach we take is, well, you have to reach those groups as well, and you have to do things, because they're part of, they're taxpayers.
True. But I think we'll have to stop there.
Yeah,
and we'll
sorry.
Continue the
we can talk about it afterwards. Yeah,
because we actually at
absolutely.
3:30, so we are actually the end of the session, so we'll have to we'll carry on. Last speaker is Claudia Mignone from INAF, and she's going to talk about the work done in Brazil in Rio de Janeiro.
Thank you. Can you hear me, see me? Okay. So I'm actually speaking here on behalf of Maria Clara Heringer Lorenzo. She's an undergraduate student of Arianna Cortesi at the Federal University of Rio de Janeiro, and she is currently writing her thesis. She's going to defend soon, and didn't get travel funding, so she couldn't attend the conference. So I'm giving the talk on her behalf, and I'm speaking on behalf of actually very large team of people that is behind the project Closer to the Sky. I'm going to give you a very quick, I'll try to be as fast as possible, but to pay honor to the project. So there's a very large team. The project is taking place in Rio de Janeiro, Brazil, but with a number of collaborators abroad in various countries that support in different ways, and I'm one of them. So what is the reason of this project? So Closer to the Sky is an open science and astronomy for development project taking place in a favela of Rio de Janeiro. The reason behind the motivation is racial inequality. So as Matthew also mentioned, sustainable development goals, racial inequality is a major global issue. Racial inequality in Brazil, I would say, is also a global issue, given that it's a country of continental size. And if you attended the talk this morning in the plenary session from Patricia, you already have some statistics about the inequality and the situation in Brazil. And as members of society, it's our duty to address racial inequality in all aspects where it's presented, including academia, including STEM, including astronomy. So Closer to the Sky takes place here. This is the PPG, Cantagallo Pavão Pomozinho. It's a favela in Rio de Janeiro on a hill. And it's actually in the southern part of Rio, close to two of the richest neighborhoods, the famous Ipanema and Copacabana beach. And you can see the photo speaks by itself in terms of the unequal distribution. Favelas score lower than neighboring areas in terms of several development indicators, such as employment rate, school abandonment, average income. At the same time, they are home to communities that have been living there for a long time, and that actually, if you ask, there's been a research from last year, and 60% of favela residents in Brazil would not live elsewhere if they had the choice. So it's a community in which people recognize themselves. Of course, they would like to be treated with respect and be allowed to live in the community where they do live and grew up without also being attacked by violence. And racial inequality speaks in terms of the population in favelas, the black population in favelas is much larger than the general population in Brazil, 67% to 55%. So this is the context where the project is taking place, how it started. It started during the pandemic with some researchers from the Observatorio di Valongo who put a telescope out there to share some views of the universe. And then it started a dialogue with the local residents, with the community leaders. And I would say that is how the project then developed and evolved, and that's the main takeaway from this project, and actually from all projects liaising or intervening in marginalized areas. So you meet the community where they are, and you design the project, you co-design it together with the community according to the local needs. So you don't just think, oh, we have something very nice. We all do, astronomers, we have nice pictures and stories of the universe, let's go and share them. No, to have an impact, intervene where there is an actual need. And actually there are several needs here, some of the SDGs, the Sustainable Development Goals that this project tries to address, including especially quality education and reduced inequalities. And that's because in the pandemic time and in general, so especially in the pandemic time in which education went online for a very long time, but also in general, children in favelas have much less opportunities to access higher standards of education as in neighboring areas. So it started with astronomy classes and also English classes. The astronomers were teaching the children. And it then evolved, it moved to Ninho das Águias. It's a cultural center on the top of the hill that I showed you. And actually that's also where the project name comes from. So Closer to the Sky, it means figuratively closer to the beauty of the universe, but also literally because many Brazilian favelas are on top of hills. And it's a beautiful little library that was built on what was previously a dumping ground. And there have been regular weekly classes for children, astronomy classes and English classes since 2022. And as you can see, there are sometimes there are a large group of children, 4 to 12, so it's a very broad age range. And that means sometimes they are divided into groups of different activities or different ages. What the project realized is that there are not many freely available educational resources for this specific target group that are not completely Eurocentric, male, heterosis, white, dominated, ableist resources. So they started to create their own resources, including elements from cultural astronomy, so the local constellations, or, for example, there is an activity about stellar evolution, comparing it to people, and of course to people who look like the people who would live in the favela, not just the people who would be in the academia, to change the makeup eventually of the people in the academia as well. A collection of that is being compiled by Maria Clara, who is created a booklet of some of these resources for her bachelor thesis. Thanks to OAD funding, so the IAU Office of Astronomy for Development funding since 2024, we were able to involve adults from the favela, artists, so in the creation of the educational resources. That means that we could pay for the material and for their time, and so this is planets with street art classes, and this is going to be Jupiter. And this is from Acme. He's the graffiti artist who has been running the workshop with children. On the same time, there's a hip-hop classes that are done after the astronomy class. So after the kids learn about the planets and astronomy, they also meet with Brasson. He's the guy with the bright red shirt. He's a hip-hop musician from the community, and then they practice hip-hop with the theme of the astronomy class. So they practice memory and also self-esteem, while they also practice what they learned in science. And that is a way to engage the adults from the community as well, and also to provide role models in which the kids can identify themselves. And actually, Brassau, in a recent interview, said that he had never seen himself in a teaching role before. So the fact that the project could offer this opportunity is another small outcome. In the videos, we since 2024, thanks to the OAD funding, there's also classes for teenagers. It's been more complicated though, because recruiting teenagers in the favela has other challenges, because once they turn 12 or 13, they have to work either in the house or to get a job and get paid. So there is also the possibility to train as astro guides as part of these classes, and the project is thinking of a crowdfunding to provide some small grants. In the future, stay tuned, because there will be some of the resources will be published as open educational resources in various languages to be also useful for similar projects around the world, along with the approach. And there's monitoring. There will be some like study monitoring the well-being of children along the theme of astronomy for mental health. These are the contacts if you'd like to follow the project. And yeah, I leave you with our motto, and I'm happy to talk about it in the next few minutes over coffee.
Thank you so much, Gloria. I think it's an excellent example of science communication with rather than for somebody, right? It's an excellent project. We can either take a question, or we can just walk with her to coffee and keep bothering her with questions as we go along. Would that be better? Yeah. Just quick announcements again. If you have any giveaways to give people, put them on the table in Sirius room. If you want to take stickers from other people, go to the same room. Last, I just want to thank the tech team again. And I taken photos of all the speakers. If you want a photo of you speaking, come and catch me. I'll WhatsApp it to you. Yeah. Okay. Thanks a lot. Thanks to all the speakers in person and online. And let's head for coffee. And you should ask her questions on the way.
Et ouais.
Here.
Oh,
Here.
just close it.
Not the Teams. Right here. But the program is wrong. Is over.
Oh, it's wrong. Ah, okay,
It's
okay.
wrong.
So we were told that the web app is the correct one. Everything else we should ignore. So, so we were told very clearly that we were told to not look at anything, but just look at the web app. So, but thanks.